In tree traversal concept, we have to visit all the nodes exactly once. And if the edge obtained in step 4 is remove an edge from Q. So these are the questions you can expect for your examination: binary tree traversal, and you just draw a graph without having the cycle. Without creating the cycle, you have to draw a graph. That's it. Hello everyone, welcome back to my last session on discrete transformation. I am Shweta, Computer Science faculty. So dear students, today I am explaining the last topic in your syllabus, that is Prim's algorithm and Kruskal'S algorithm. Very important concept. In my last session, I have discussed about the tree structure and the definition of tree, properties of tree and terminologies of tree, and also I have discussed spanning tree and minimum spanning tree. Is it right? So minimum spanning tree can be classified as Kruskal'S algorithm and Prim's algorithm. So first topic is Kruskal'S algorithm. So you can expect any question on this topic, Kruskal'S or Prim's algorithm. So first one is Kruskal'S algorithm. Kruskal'S algorithm is used to find the minimum spanning tree for a connected weighted graph. So what is this connected weighted graph? So here I draw a connected weighted graph. Is it right? So now here you have one connected weighted graph. So for this we are finding the minimum spanning tree by using this Kruskal'S algorithm. The main target of this algorithm is to find the subset of edges by using which we can traverse every vertex of the graph. So by using this Kruskal'S algorithm, we can find the minimum spanning tree by using the subset of edges. Example, here how many vertex are there? 1, 2, 3, 4 vertex and 1, 2, 3, 4, 5 edges. Is it right? Now I'll apply the Kruskal'S algorithm concept. So here you have edges and weighted edges, right? So now I list all the weighted edges. So this is A, B and C, D. Here you have 4 vertex and 5 edges. So first I'll draw a minimum edges, that is A to D is minimum among all these edges. A to D is AD is equal to 1 and next is CD is equal to 2 and list according to their weights. Next is BD is equal to 3 and AB is 5 and AC equals 5. I have listed weights of the edges according to their weights. So now AD is a minimum value, minimum edge, CD is the next minimum and BD is the next minimum, AB and AC. Now I have drawn, so here I'll draw a minimum spanning tree according to their weights by using this Kruskal'S algorithm. So now the first least edge is AD. I'll draw AD, edges 1. And next least is CD. I'll join this C and D. Weighted is 2. And next is B and D. B and D is 3. And next weight is AB is equal to 5. If I joined AB, so we'll get cycle, right? So what is tree? Tree means a acyclic graph, right? So what is minimum spanning tree? Minimum spanning tree does not have any cycle. So AB, I'll not connect this A and B edge because it has maximum weight. And if I join this, it will get cycle. And next is A and C. If I join this A and C, again you will get one cycle. So I'll skip this edge, 2 edges AB and AC. According to their weight, it has a maximum edge, right? So AB is equal to 5, AC is equal to 5. So I'll skip this because it will connect the cycle. So this is your Kruskal'S algorithm example problem. So now you can give this example for your examination. So just write the definition of Kruskal'S algorithm and you can give any one example graph. So very simple concept. First list all the weights of each edge and according to their weights, you just draw a graph without having the cycle. Without creating the cycle, you have to draw a graph. That's it. So algorithm for Kruskal'S. So here, create a forest in such a way that each graph is a separate tree. So you have to create a forest in such a way that each graph is separate. Each graph has separate tree and create a priority queue. So according to their weights, we have to give the first priority to the least edge that contains all the edges of the graph and repeat steps 4 and 5 while queue is not empty and remove an edge from queue. And if the edge obtained in step 4 is remove an edge from queue, connects 2 different trees, then add it to the forest for combining 2 trees into 1 tree and else discard the edge. So this is an example for Kruskal'S algorithm. So now I'll give one more example for Kruskal'S algorithm. So this is one example graph. Now I'll apply Kruskal'S algorithm. So according to their weights, you can list all the edges. So the least edge is D and E. If you have 2 edge values are same, so you can list 2 values also. So the least is DE, DE is equal to 2 and the next least is BD, BD is equal to 3 and FC or CF is equal to 3. And the next least is BE, BE equals 4 and CD equals 4. And next least is 5, AC equals 5. Next list is AB, AB equals 6 and AF equals 7. So according to their weights of the tree, so I have listed the edge weight. Now by using this least edge, we can draw a minimum spanning tree. So now the least comes from DE. I join this DE edge, weight is 2 and B and D. BD is equal to 3 and next is FC. So here I'll draw F and C. FC is equal to 3 and BE. So BE is here. If I draw this BE, we'll get cycle, that is closed path. So I'll skip this B and E. So you can skip this edge B and E. And next least is CD. I'll join this CD. And next is A and C. A and C, weight is 5. And next is A and B. So if I join this A and B, we will get cycle. So I'll skip this A and B. A and B is equal to 6. I'll skip that edge. Next is A and F. So if I join this A and F also, you will get a cycle, right? So again, I'll skip this edge A and F. So now we got a minimum spanning tree. By using Kruskal'S algorithm, we got a minimum spanning tree. So this is an example and about the Kruskal'S algorithm. Very simple and easiest algorithm is Kruskal'S algorithm. And the next one is Prim's algorithm. So here, Prim's algorithm to find the minimum cost spanning tree. So here also we are finding the minimum cost. By applying Kruskal'S algorithm, we find the minimum cost. And here also we are finding the minimum cost uses the greedy approach. So it is a greedy approach and Prim's algorithm shares a similarity with the shortest path first algorithm. Here we are finding the shortest path for connecting from one vertex to another vertex. We are finding the shortest first path. So what is the role of this Prim's algorithm? So in Prim's algorithm, we are finding the shortest path first. Clear? So now algorithm, very simple algorithm. So same as it is we have studied in a Kruskal'S algorithm, you can write the steps for Prim's algorithm also. Now, I'll give one example for Prim's algorithm. So, A and B, 7, 8 and 3 here. C to A is 3 and B to D is 6 and D to A is 2 and C to A is 4 and here F, E to 5 and 2. Now, this is an example graph. By using this Prim's algorithm concept, I can draw a minimum spanning tree. Now, first step is you have to choose a shortest path for connecting from one vertex to another vertex. So, A is connected to B and A is connected to C. Which is the shortest path here? So, A to B is shortest path. I'll write it here. So, A to B is shortest among this A to B and A to C. Now, B is connected to D and B is connected to C also. Which is the shortest one among these two? So, here I have 3, here I have 6. So, here for connecting from A to C, I skip this 8, right? So, I have selected this 7 and now I'll compare these 3 edge value, that is B is connected to 3 and 6 and I'll consider this 8 also. Clear? So, now before that I have selected A to B is equal to 7 and have skipped this A to C is 8. Now, I'll take this 8 also. I'll compare this which is the least among these 3 value. So, B to C is the least value. I'll join B to C. Next. And now, C is connected to D. C is connected to E also, which is the least among these other values. So, I have selected 3 also. Now, I'll add this 6, 4, 8 also because in the previous step, I have skipped this edge value. So, now I'll compare this 3 values with this value C to E and C to D. So, C to E is the least value, least edge is C to E. I have selected this. And next is D is connected to F and D is connected to E also. Which is the least value among these 5 values? So, here I have 8, 4, 6, 2, 5 and 2. So, here you will get 2 values, that is D to F, that is D to E is 2 and again E to F is 2. Clear? D is connected to F and D is connected to E. Among these value, 2 is the least value I have selected and here D is connected to F, E is connected to F. So, 2 is least value, E to F is least value. So, I have selected this edge. I have skipped this 8, 4, 6, 5 have skipped and have selected the edges 7, 3, 2, 3 and 2. So, this is called Prim's algorithm. So, according to their weight, according to their weightage, you can select the edges. So, keep on adding the edges. So, you will get the minimum spanning tree. This is an example for Prim's algorithm and Kruskal'S algorithm. So, you can give this example for Prim's and Kruskal'S algorithm. So, in exams, they will give the diagram. So, you have to write the minimum spanning tree according to their weightage. So, here in Prim's and Kruskal'S algorithm, we are finding the shortest path first, right? The last topic is tree traversal. So, what is this tree traversal? Very, very important question. So, in tree traversal, visit each node exactly once. So, here in tree traversal concept, we have to visit all the nodes exactly once. So, what is the definition of tree traversal? The process of visit each and every node exactly once, that is called as tree traversal. And in tree traversal, we have 3 types, that is in order, You can expect this question for 7 marks. In-order traversal, pre-order traversal and post-order traversal. So these three are the types of tree traversal: in-order, pre-order and post-order. So now by using this three traversal concept, we can visit each and every node exactly once. So in-order means, so I'll take one example for in-order. So now this is root and here this is A, root A, and this is B, and here it is C. Now B has 2 children, that is D and E, and C has 2 children, that is F and G. Now this is called root and this is left subtree, and right subtree. Left subtree and right subtree. So now I have 3 part here: root node, left subtree and right subtree. Now I'll apply this tree traversal method, visit each and every node exactly once. That is called as tree traversal. So first I'll write the in-order traversal for a given tree. This is your question. So they will give one graph. Write the in-order traversal for a given tree. Now I'll use this tree. I'll draw a in-order traversal. In-order traversal, root tree has to be in a middle. Root, here it is left subtree and here it is right subtree. This is a concept of in-order. So now I'll write the in-order for a given graph. So first should be in a left subtree. That means here, if you are considering this left subtree only, so first you have to write the left subtree. This is left subtree, this is right subtree, and this is root. Is it right? So what is the graph now? D, B, E. So in order is D, B and E. So left subtree is completed. D, B, E. So root means here it is B. If you are taking this part only, B is a root node and it is left subtree and it is right. So now B should be in the middle. That is called as in order. So D, B, E. And next is root. That is A. Root should be in the middle. So root should be in the middle. And next is F, C and G. F means left subtree, C is root tree and G is right subtree. This is called as in order. So in order tree for a given graph. And next is pre-order. So pre-order means root has to become in a first. So root, left subtree, right subtree. Is it clear? Now, so how to write the pre-order for a given graph? Root should be in a first position. Root node is A. And next is, again, I'll take this left subtree. So again, root, left subtree, right subtree. So B, left is D, right is E. And again, the next right subtree, I'll take this right subtree. So first is root and next is left subtree and next it is right subtree. This is pre-order. And what about the post-order? Post-order traversal. So post-order in the sense, root has to be in the last position. So now post-order is, so here I'll take this first part, left subtree. So first left subtree and next is right subtree, then it is root. So I'll write the graph D, E and B, and again it is F, G, C and A. So A means root. Root has to be in the last position, that is post order. So this is called as in order, post order and pre-order traversal. So for this question, you can expect the algorithm also. Write the algorithm for in order and algorithm for post order and pre-order. So how to write the algorithm? So first you have to write the first step, step 1, that is in order means. So first is left subtree. So left subtree, step 2 is root should be in the middle, and last is right subtree. Clear? This is in order. And for post order, pre-order is step 1 is pre-order means step 1 is root node and step 2 is left subtree and right subtree. And for the post order, so for post order left subtree, right subtree and then it is root node. So this is about your tree traversal concept. Very easiest and simple concept. Definitely you can expect this question for 7 marks. In exams, they will give you the tree. You have to write the in order, post order and pre-order for a given graph. Is it clear? And the last topic is binary tree. So what is this binary tree? So the tree consists of, the degree is 2. It has 2 children and siblings, that is called as binary tree. So what is the siblings and children? So here the root is A. Parent of this 2 node is, this is a parent of this 2 node and this is a parent of these 2 node and this is a parent of this 2 node. Now these 2 are called as siblings. And also called as these 2 are the children of this parent. This is called as siblings. Clear? So these are the questions you can expect for your examination: binary tree, tree traversal and types of tree traversal, and minimum spanning tree and spanning tree, types of minimum spanning tree, that is Kruskal'S algorithm and Prim's algorithm, and the definitions and properties of trees and some definitions, that is terminologies of tree, leaf node and root node, degree of a node, siblings and level of tree and height, depth of a tree. You can expect this question for 2 marks also and 7 marks, 8 marks. So this is about your 4th unit called graph theory. So dear students, I have completed all the syllabus. I have explained so many problems in your discrete transformation. So now it's time for you to work. Please start working properly. So definitely you can expect 80 out of 80 in your paper. Clear? So this is about your syllabus. Thank you so much. Thank you all. So please practice well. All the best for your examination. Thank you all. Take care. Bye-bye.